All right, Titans. Hello and welcome to Chapter 3, Section 6. In this section, we're going to solve literal equations. So go ahead and write down your heading, 3.6, Solving Literal Equations. All right, we have two important terms for this chapter, Chapter 3, Section 6, and that is, first of all, literal equation. A literal equation is an equation that involves two or more variables, such as d equals r times t. Distance equals rate times time. That's a literal equation. It's an equation that contains two or more variables. A formula is a type of literal equation that states a rule for a relationship among quantities. So distance equals rate times time is a literal equation, and it's also a formula because it states a rule for a relationship among quantities. There is a relationship between the rate that you travel at and the time it takes to travel. So a literal equation is an equation that involves two or more variables, and a formula is a type of literal equation that states a rule for a relationship among quantities. The first key skill of Chapter 3, Section 6 is your ability to manipulate a literal equation. In other words, what you're going to do is you're going to use your algebra equation solving skills to take a literal equation and rewrite it so that the desired variable is isolated. This is very useful to us in Chapter 5 when we need to write equations into slope-intercept form, and it's also very useful to us when we're working with various formulas, as we'll talk about later. Let's go ahead and jump in and do an example. So go ahead and write this in your notes. Example number 1. The directions here are to solve for r. When they say solve for r, they mean isolate r. So our goal here is going to be to take the equation 5q plus 2r is equal to p, and we're going to want to rewrite this so that the variable r is isolated. To get the variable r isolated, the first thing we're going to want to do is get rid of 5q. So to get rid of 5q, we want to get rid of the whole thing. 5q is being added there. It's a positive 5q. So we're going to go ahead and move it to the other side. When 5q changes sides, it's going to change signs. So now it's a negative 5q plus p. When 5q changes sides, it changes signs. Now we're going to get the variable r by itself. To get r by itself, we got to get rid of the number 2. 2 is being multiplied by r, so we would divide both sides by 2. And we have to divide the entire side by 2. So our final answer is negative 5q plus p, all of that divided by 2. That's our answer. Once again, these are different because when you solve a literal equation, you're just rewriting it in a different form. You're not going to solve it to have an answer of 5 or 10 or 32 or negative 20. These, when you solve them, you're just taking it and putting it in the desired form. That is example number 1. All right, let's go through a couple more of these. We'll make them fairly quick. Let's go over d equals m divided by v. They want us to solve this for m. So to solve it for m, we got to isolate m. So to get m by itself, we'd have to get rid of v. We're dividing by v, so what would we do to both sides? Multiply by v. So the v's cancel, and you're left with v times d is equal to m. That's simple. You use your equation solving skills to isolate the desired variable. So to get m by itself, I multiply both sides by v, and I'm done. m equals v times d. That's solving a literal equation. All right, let's jump to the second one here. A equals p plus L. They want us to solve this one for p. So to get p by itself, I got to get rid of this plus L. So to get rid of a positive L, I would go ahead and subtract L from each side. When I subtract L from each side, the L's cancel, and I'm left with A minus L is equal to p. That's simple. Isolate the variable p, I gotta get rid of plus L, so I subtract L from each side, and now I've solved for the letter p. Alright, example number 3 here. C equals 2 pi r. I'm gonna solve this for r. So I want to get rid of 2 and pi. 2 and pi are being multiplied. So can anybody guess how I'd get rid of 2 and pi? You guessed it, I would divide. Divide both sides by 2 pi. So the 2 pi's would cancel out there. I'd be left with r, and r equals c divided by 2 pi. That's my solution. Once again, remember, when you solve a literal equation, you're just rewriting it so that the desired variable is isolated. Alright, last one we got here, 3x plus 4y is equal to 12. They want us to go ahead and rewrite this so that the variable y is isolated. So to get y by itself, I'm going to take the 3x and move it over. So now I have 4y equals negative 3x, change sides, change signs, and that positive 12 did not move, so it stays plus 12. Now to get y by itself, I divide everything by 4. So my answer is y equals negative 3x plus 12 divided by 4. And if I wanted to, I could simplify that a little bit, because I could divide both terms by 4. And I'll go ahead and rewrite this up top on the screen here, but I could rewrite that as negative 3/4 x plus 3, because 3 divided by 4 is just 3/4, and 12 divided by 4 is 3. So I could write it like that as a final answer. That would be totally simplified. So, ladies and gentlemen, those are some additional examples of solving literal equations. Remember, when you're solving literal equations, you're just taking it and rewriting it in a new form where the desired variable is isolated. Alright, skill number 2 on this teaching video is your ability to use formulas to solve problems. So what they're going to do is they're going to give you a formula, and then they're going to give you values. You must take those values, plug them into the formula, and solve for the variable which is unknown. So in this case, we have v equals s over t. They tell us that v is 25, and they tell us that s is 1500. We must solve for t. So to solve for t, 1500 divided by what number is 25? Some of you guys might try to do that in your head. The easiest thing to do is get the variable out of the denominator. So you multiply both sides by t, the t's cancel. So now you have t times 25, which is 25t equals 1500. And then as you can see, we would divide both sides by 25. And t would then equal 1500 divided by 25. And obviously 25 can go into 100 4 times. So it would go into 1500, 15 times 4, which would be 60. So t would equal 60. So once again, all we did there is we took the values we know, substitute them in, and then solve for the missing variable. Alright, let's go ahead and practice our second skill one more time here, and then we'll be done with our teaching video for this evening. Here's the application, and it's of temperature. So they give us the formula right here to convert from degrees Celsius to degrees Fahrenheit for temperature. So on the first one, A, they tell us that the Fahrenheit reading is 104. So we take 5/9 times 104 minus 32. Once again here, all I did was take the value they gave me and plug it into the formula. So 104 minus 32, that would come out to be 72. And I'm going to write it as a fraction because now I got to multiply 5/9 times 72. Cross reduce the 72 and the 9 down to an 8 and a 1. Multiply straight across and I get 40. So it would be 40 degrees Celsius. So 104 degrees Fahrenheit, which is quite warm, would be 40 degrees Celsius. Once again, I was able to figure that out by just taking the value they gave me and plugging it in to the formula. Alright, the last example we're going to get rid of B here. We're just going to do C to end things today. To end things with C here, what we're going to do is we're going to go ahead once again and take our formula and plug in our degree Fahrenheit, which is 23. Then I would do the math here. 23 minus 32 in parentheses comes out to be a negative 9. And then 5/9 times negative 9, I could cancel the 9s to be 1s. And that would multiply across to be negative 5 degrees Celsius. So if it was 23 degrees Fahrenheit, it would be negative 5 degrees Celsius. Alright, Titans, that's the teaching video for tonight. Make sure you have these examples down in your notes. Come to class on Monday ready to go over the information and put it into practice. Thanks for listening. Have a great evening.
Made with Doodlecast Pro.